Alright, so I'm back, and we are going to be doing the problem 19 for the AMC 10B. So it says that rectangle ABCD has AB equal to 5 and BC equal to 4, and just a whole bunch of this. So we can mark it up, and we'll go right over here. So we'll mark this up in just right now. So this is a little bit small, sorry about this. Make it a little bit bigger so we can draw it more precisely. It's kind of difficult to draw, so sorry for my bad geometry drawing skills. So I believe it's something that looks like this, and then just like that. And we are trying to find PQ over EF. It's going to be PQ. This is going to be EF. So, and it just lists a bunch of values. So DF is 2, EB is 1, so this is going to be 2, 1. I think this was 4, and this whole quantity is 5. And this one is 1, and this means this one is 3. So, oh yeah, and this one must be 3 also. And this must be 4. So using all these values, I mean, this problem is definitely solvable using coordinates and slopes. But however, this is the AMC, you cannot spend that much time, and it takes extremely long to do something with coordinates in a question like this. So pretty much the only resort to do is similar triangles. It's kind of a rule, I'd say. So we can see that triangle ABQ is similar to triangle QFC, and that's pretty much the only pair of similarity that you can pretty much find. There isn't really any more similar shapes, and these quadrilaterals are not similar, unfortunately. This one and this one are not similar. So, because it's 1 over 2 is not equal to 3 over 4. So we're going to have to just stick with these. And using this, we know that QE over QP is equal to AE over FC, and we know that these two are similar because of all the angles are congruent. As you can see, they're all congruent, so that means these triangles are similar. And we know the reason why we choose QE and Q. Wait, did I say QP? Wait, sorry. Wait, QE over QP. Oh no, sorry, not QP. QE over. Wait, no, this is. Sorry. I mean PE over PF. Yeah, I was kind of confused because Q was right above it. So QP over PF. I'll just erase this, I guess. It's taking a while. So we have PE over PF is equal to AE over FC. And doing this, we know that PE over PF is equal to 4 over 3, which means that 4 PF is equal to 3 PE. So now, how do we continue here? So pretty much the only way to truly find what EF is use the Pythagorean theorem. As you can see, it is given that this is 1 and then this base is 3. So if you just draw a line right through here, you can cut Let's erase this. We can cut to this into 2 and 1. And since this whole height is equal to 4, because 3 plus 1 is 4, EF is going to be equal to the square root of 4 squared plus 2 squared, which is equal to square root of 20. And usually at the end you simplify, but in the middle, when you need to use EF for some calculations, it's not suggested that you do it. And we know that PF plus PE is equal to EF, which is equal to the square root of 20. So now we can just substitute in PF or PE, and you would want to choose PE, and the reason being is because PE includes PQ, so you're going to be more likely and you're going to have more options. And if you chose PF, then you need to subtract the whole thing, and it would just be more complicated. You would only need to use PE. So in that case, we're going to isolate PF so we can have the plugged in terms of PE. When we plug it in, it's in terms of PE. So plug it back into this equation up here is, or 4 times is equal to 7 PE. So now 4 root 20 over 7 is equal to PE. This time, you might be thinking this is taking a lot of time already. And yeah, you can look at the answers, and the only one that would seem related to this is 10 over 91. And the reason being why you would choose that is because P or QE is going to be just some number subtracted by this. So PQ is equal to 4 root 20 over 7 minus, like, let's say x. But in the end, whatever x is going to be, it's still going to be somewhat in the terms of these it's going to have this radical still, and it's going to be somewhat in terms of this. Because you can't really cancel out a radical by subtraction unless if they're equal. But otherwise, you can't really just cancel out this radical. And if they were equal, then it would be 0. So it would not make any sense. So it would have to be in terms of root 20 over 7. You can't just change the denominator or not really change the denominator, but change the main multiple of the denominator. And you can't really remove this radical. So, did I just say PQ? Yeah, PQ would have to be somewhere in terms of this. And we're trying PQ over EF. And PQ over EF should be something around this. So it should be in the form A root 20 over 7. It should be something like that times B. So A root 20 over 7 times B. And, divided by EF. This is PQ right here. So PQ is this. And then EF, as we already found, it's root 20. So in that case, root 20s do cancel out, but the only ones that have a multiple of 7 in the denominator is going to be 91. And still, 10 is kind of similar to root 20, but none of these at the top are similar or correspond to root 20. So by using the answer choices and saving a lot of time, you know that the answer must be D, because by eliminating, you can just eliminate every other choice. And you still could do that from the beginning. So if you just found EF is equal to square root of 20 off the top, you know that none of these include anything near square root of 20 except for 10 over 91. So therefore D would be your answer for problem 19. And pretty much the only way to solve this Otherwise, is by creating more similar figures, and it would just be too long creating these similar figures, or creating extraneous similar figures, or you could just use coordinate bashing, but that would also take too much time, and you'd be better off just by selecting the best answer in this case.